Yeah, it's just it's just like changing something old and clunky to a new car that's faster and easier to drive. All right, so let's go. I'm Louis Patrick. I'm study at the University of Sherbrooke, and I was an intern and part-time worker for Pinax in the last 8 months. What I was tasked to do now 8 months ago was follow the MIPS program with the graph. So what the MIPS program tries to do, I think it's short. It's for merit incentivized program. So what we were trying to do is take the hosted service from the graph, so the service that they were providing, and make it decentralized with a lot of people launching their own indexers and serving queries. So that's what I followed, and it was a couple of steps from testnet and then to mainnet and having a bunch of chains, and now it's really all over the place. So there's a lot there. So that was my introduction to Web3 and the graph. So what is a graph? It's a decentralized protocol for indexing and querying blockchain data. What it tries to do is provide a central place where you can get all your chains, query data. You can just start to query them easily with some API keys. You can do whatever you want with just the information you need, and it wants to be cheap, easy to use, and also decentralized. Like I talked earlier, there was the hosted service. There still is the hosted service, but what it tries to do now is launch all of this into a decentralized way. So what we see here into the Graph Explorer is all of these subgraphs that are maintained by the community. So all of these are hosted on an IPFS server, but there are the queries are served by the community of indexers and everyone that's working for the serviceability. So here we can see an example of a subgraph. Um, Subgraph that's on Ethereum. It's the Uniswap one. It's one of the most popular ones, and it's recognizable because of the unicorn. So it's just a page with the overview of this subgraph. It's been created 6 months ago. That's pretty long on the graph. You can see a bunch of indexers, the curators, and you would be able to go into the playground, test some queries, get an MPI. So that's it. That's what a subgraph is. So, how is Pinax involved? What we at Pinax, we profit from infrastructure, and we try to serve these queries. So we built up a indexer, which is on mainnet. This is the one I'm showing you here. It is live from this January. So we worked past with only testnet. We tested it something. We followed the MIPS program. Then we were ready for mainnet. So we staked a bunch of tokens. We got some delegators too that helped us, which I'll get in a bit. And yeah, we were able to collaborate with Streaming Fast and the Graph to make this happen and open our indexer. So now we're serving. Right now, I think we're serving 4 subgraphs at the moment, and we're serving queries there. So, uh, how does the graph work? What we see here is really all of the actors, and then we'll see what the indexer does here in a bit. But how it works, there are the subgraphs here, which are developed by developers. So they develop subgraphs to be able to query some data. After that, you have the curators that signal tokens to the subgraphs. What it does is it just says like, this is subgraph is interesting. I want indexers to take interest in this and allocate to these to be able to serve queries. So the curators are semi-technical people that just have some interest in a certain subgraph and want to make it more popular. So then the indexer allocates to these subgraphs. Which incentivizes them too is that the more signal tokens there is, the more indexing rewards and or query fees are added to the indexing service. So the indexer to be able to allocate to some subgraphs and be a real indexer has to stake 100k GRT on their own. But after that, you can have delegators that trust GRT in you, and you're able to allocate more resources to these certain subgraphs. and make more GRTS rewards after that. What you need to do as an indexer is share is have a sharing program with a certain percentage that you give back to your delegators once you get the rewards. So after that, what happens between the indexer and getting the data? This is where it gets interesting for us. So this is what's behind the black box between the graph network and our indexer, which the box here just sends the queries to all the indexers that are servicing these subgraphs. So here are all the containers, the basic containers at least, that run into an indexer stack. What we used to do this was a Docker inspired from the Steak Squid one. We just pulled it and made it our own with what we had previously that we didn't need, which we already had in our infrastructure. So we just had the graph stuff to finish. So this is a basic configuration, beginning with the indexer service that serves as a connection and just sends the traffic through the graph node then. So what the graph node does typically is a graph node would be connected to a archive node from the chain that you're trying to index. So we can take Ethereum, for an example. You would need an archive node, Ethereum, which is pretty bulky. It's a big piece of tech that you wouldn't normally host yourself, but we have that as Pinax because that's one of the things we do, and one of the things we can do. We have a bunch of them, and they run um, in a parallel way, so we can always have some fresh data. But it would the graph node would pull this data from the Ethereum nodes with the subgraph event based GraphQL. So it would only pull this data, put it in a Postgres database, and then when the queries would come in, the graph node would just query the Postgres database and send back the answers. So typically, this is how it would work. Now, what we did afterwards, after we put out our testnet, after we put out our mainnet, is that we tried to use our Firehose endpoints because we had that too. So for doing this, we had to change a couple of things, but mainly it was into our graph node setup. So in the graph node config template, we just had to change some of the things how it was done. So change the provider token because you need a token to connect to our Firehose endpoint. We changed some of the features, but basically this is how it's done. Then we had to because when we did this, there wasn't all of the graph node versions that were compatible with this, so we had to get the right image. But I think now it's supported by all of the with the latest graph node version. So this is what we did, and then we were able to use substreams. We were able to use Firehose for providing good data. So we were able to use something that was much 2 to 3 times faster than the Ethereum archive node, and it's easier for us at least to maintain a Firehose endpoint instead of an archive node that is not always reliable, especially the Aragon ones. So that's what we were able to do. So there's just a list here of some of the changes that we did and the networks that we did. So we, like I said, we're working on mainnet, testnet, and newly we're working on Arbitrum. So Arbitrum is a cheaper L2 network because every time you send queries to, not send queries, but you make allocations. These are transactions on the network. Ethereum can be a bit pricey, so Arbitrum tries to really make it cheaper for indexers and everyone in the graph to get just more for themselves, because right now the operating cost is a bit high. So going to Arbitrum is really something we're working on to make it cheaper. After that, using substreams, it's only the chain information that is different. So you need just a Firehose endpoint for the certain chain instead of an archive node. And it will be faster to synchronize subgraphs because it's easier to get this data faster. But it's still in early stages. So what could be done here instead of going through the graph node would be directly to go into substreams. So it's a bit how it's done on the graph. So you have your GraphQL scheme and you query something, then it goes through all of this. But instead, substreams work in a similar way, where it's the extraction layer that you could just run the substreams directly from the graph, and it would just query your Firehose, and data would be there lightning fast. So, what is Substream's role in this? It's better tech, but it needs more support right now and developers. So that's where we're here. It will be able to sync faster. What I didn't talk about is that the archive nodes, and when you sync subgraphs on your graph node right now, it can take hours, but it can take days and weeks for bigger subgraphs like Uniswap that I mentioned earlier. These can take a while, and if something is wrong with the subgraph, or anything fails, you have to do it all again. So having a couple of days of development like cycle is really frustrating, and it must change. So it must be faster for us to develop better software. Um, for an indexer, setting up a substream is not necessarily easy. Like I said, you need the Firehose endpoints, and there are no really providers right now, and that's what we're kind of doing. But right now, you can get some archive node endpoints with some certain side with quick nodes or something like that, but you can't really get a Firehose provider where you can use substreams. But it is a fast extraction layer, but you need Firehose. But it's definitely better. So yeah, that's basically a presentation. That's how we used substreams um, to make it faster on the graph, and just push all of the graph tech further.